The first step to solve these equations algebraically is I'm going to assign each equation a number. Now my goal of my first step is to go ahead and eliminate a variable. So what I'm going to do is I'm going to multiply equation number 1 by 2, and then I'm going to add it to equation number 2, and my goal will be to get rid of the y's, to eliminate the y. So if I multiply question 1 by 2, I'm going to have 8x plus 2y plus 6z is equal to 2. And I'm going to add it to equation number 2, which is 2x minus 2y plus 6z is equal to 11. I'm going to add those equations together, and when I do, I end up with 10x plus 12z, because when I add a 2y and a negative 2y, they cancel each other out, is equal to 13. Now, my next step is I want to go ahead and eliminate that same variable. So if I look at my equations, I know that I can multiply equation 1 by negative 3, and I can add it to equation number 3. And again, if I look here, I know that I have a 3y here, and if I do negative 3y here, then I can eliminate my y's. Okay, so if I multiply equation number 1 by negative 3, that's going to give me negative 12x minus 3y, negative 9z is equal to negative 3. And my third equation is negative 6x plus 3y plus 12z is equal to negative 4. When I add those together, what will happen is I end up with a negative 18x. My y's will cancel each other out. Plus 3z is equal to negative 7. Okay, so now I'm left with two equations that I can use to eliminate further. So I'm going to give those equations a number. I'm going to give this one the number of 5, and my last equation, I'm going to call that equation number 7. Okay, so when I look at those two equations, I know that I could add those together and isolate for x in this case. So in my third step, my plan is to multiply equation number 7 by a negative 4, and then I'm going to add it to my equation number 5. So if I multiply my equation number 7 by negative 4, it will give me 72x minus 12z equal to 28. And if I add it to equation number 5 as is, which is 10x plus 12z is equal to 13, when I add these together, I'm going to eliminate the z, and I'll be left with an x. So I'll have 82x is equal to 41. Divide both sides by 82, and I'm left with x is equal to 1/2. Now I want to go ahead and solve for another variable. In this case, I want to solve for z. So what I'm going to do is I'm going to substitute x is equal to 1/2 into my equation number 7. So I have negative 18 1/2 plus 3z is equal to negative 7. That'll be negative 9 plus 3z is equal to negative 7. I'm going to bring this up here, ran out of room. So I'm going to have 3z is equal to negative 7 plus 9, which will be 2. So z is equal to 2/3. Now my next step is going to be to substitute x is equal to 1/2 and z is equal to 2/3. And I'm going to put that back into my original equation, which was 4x plus y plus 3z is equal to 1. So I'm going to have 4 times 1/2 plus y plus 3 times 2/3 equal to 1. My 3's will cancel. 2 goes into 4 twice. So I'm left with 2 plus y plus 2 is equal to 1. And that'll give me y is equal to, this will be 4 over to the other side, will be minus 4. So 1 minus 4 will be -3. Our final step when solving systems of equations algebraically is to make sure that the solutions that we found fit into all 3 equations, which means when we substitute them in, the left side will equal the right side. So we're going to check all of those equations. So in the first equation, if we substitute, x is 1/2 plus -3 plus 3 and 2/3. Test and see if that's equal to 1. That'll give us 2 minus 3 plus 2 is equal to 1. So I'll end up with -1 plus 2 equal to 1. 1 does indeed equal to 1. Now in our second step, substitute the 1/2 plus -3, get my 2 there, plus 6, 2/3, and we're testing to see if that's equal to 11. 2's will cancel out. That'll leave us with a 1 minus 6. 3 goes into 6 twice, plus 4 equal to 11. Sorry, this should be a minus sign, so that means that will be a plus. So we have 11 is equal to 11. That is correct. And in our last equation, we're going to substitute the minus 6. X will be a 1/2 plus 3 times -3 plus 12 times 2/3, and we're going to find out if that's equal to -4. So 2 goes into 6 3 times. That'll leave us with a -3. 3 times -3 is -9. 3 goes into 12 4 times. 4 times 2 is 8. And we're testing if that's equal to -4. So we have -12 plus 8 is equal to -4. -4 is equal to -4. It is, in fact, correct in the third equation too. So we can conclude with certainty that x is equal to 1/2, y is equal to -3, and z is equal to 2/3.